Okay, so I want to make kind of a short video, mostly definitions, still on chapter 16 that you're working on in our textbook. So the first thing I want to talk about is a random variable, and we've talked about, of course, random variables in algebra frequently. In probability theory, we have a random variable represents a numerical variable whose value depends on the outcomes of a chance experiment. A random variable associates a numerical value with each outcome of a chance experiment. So and we saw some of these in some of the examples you watched in class yesterday. So there are two types of random variables. One is discrete, and a discrete random variable is a countable number of possible values, and it answers the question, how many? Then continuous random variable is the range is an entire interval of possible values. So that, for example, all real numbers, and it answers the question, how much? So discrete is countable, continuous can take on any value on an interval. So I'm going to give you some examples, and we're just going to kind of briefly go through. If we were in class, I'd have you like shout it out, but you might be watching the video independently and you might not want to shout it out, but you can kind of think, okay, would this be discrete or continuous? So the first one, the number of courses you will pass this semester. So I would start by thinking, is this countable or not? Well, yeah, how many courses? Hopefully you're going to pass all of your courses. So if you have 6 courses, you'll pass them all. So that would mean that it's discrete. The second, the length of time you will sleep tomorrow night. So this one would be continuous because it's any value, it can be hours, minutes, seconds, as far as the length of time you sleep. So it's not countable. The distance you drive tomorrow. Again, not countable, so this would be continuous. So it can be decimal values, fraction amounts, so it's continuous. The number of students in your next class. Well, that's definitely countable, which means it's discrete. The amount of gasoline you buy next week. That one would be continuous because it could take on any decimal value. The number of pens you own. Well, you could count them, right? So it would be discrete. The thickness of your statistics book. That would be continuous because you're going to measure that, and so you're going to have some kind of fraction or decimal. The time required to complete a phone call to a prospective client. That one would be continuous. The number of calls to the client. You could count that, so it's discrete. The number of items purchased by the client. Again, it's countable, so it's discrete. The shipping weight of the items. Again, that's measurable, but not really countable, so it's continuous. The distance the items are shipped. Again, continuous. So then the probability distribution of a discrete random variable x gives the probability associated with each possible x value. Each probability is the relative frequency of occurrence of the corresponding x value when the experiment is repeatedly performed in the long run. So you saw some examples, I think, on the previous video where you watched number 6 and number 14, and I made some probability distributions on those where x represented the possible outcomes, and then we had a probability associated with each of those outcomes. So that would be considered a probability distribution. So you do have some problems that you're going to do as well from this assignment. Oh, wait, nope, forgot my final thought. Forgot I had one more slide. A final thought. 2 random variables were gossiping and thought they were discrete by whispering, but I heard their chatter continuously. I know, dumb joke.